This video is for section 13-4, Applications of Geometric Progressions. Let's do a couple example problems. A certain bacteria organism can divide into two every half hour. Starting with one organism, how many would there be after 5 hours? At the start, at the 0 hour mark, there is one organism. At the half hour mark, that would have split into two organisms. There would be two of them. At the 1 hour mark, each of those would have split into two, and there are now 4 organisms. At the 1.5 hour mark, each of those split into two. Now there are 8 organisms, and so on. This is a geometric sequence where every time it's multiplying by 2, so our value of r is 2. Now, one way to find out how many bacteria there are in 5 hours is to keep extending that list until we reach the 5 hour mark. But a faster way might be to use the general formula for a geometric. It is T sub n equals a times r to the n minus 1. But what value of n do we need to use to be the number of bacteria after 5 hours? In the sequence that we've written so far, the 1.5 hour mark was the 4th term in the list. So the 2 hour mark is the 5th term, the 2.5 hour mark is the 6th, the 3 hour mark is the 7th, the 3.5 is the 8th, the 4 hour mark is the 9th, the 4.5 hour mark is the 10th, and the 5 hour mark is the 11th term in that list of numbers. We want to find T sub 11. Our value of A is 1, the first number in the list. Our value of R is 2. It's doubling every time. And for N, we used 11. So the 11th term in our list is equal to 1 times 2 to the 10th power. Let's evaluate that on a calculator. 2 to the 10th is 1,024 bacteria. Next example. A rich relative decides to gift you 1 cent on January 1, 2 cents on January 2, 4 cents on January 3, and so on for the entire month of January. How much is the last day's gift? So how much do you receive on January 31st? Notice the pattern that's happening from term to term is doubling, so r is equal to 2. We have a geometric sequence. If we write out a few of the terms, it looks like this. 1 cent, then 2 cents, then 4 cents, then 8 cents, and so on until we get to January 31. Well, we don't want to take the time to list this out 31 times to get our answer. Let's use the formula. T sub n equals a times r to the n minus 1. And we want to know what's the 31st number in this list. The value of a is 0.01, 1 cent. The value of r is 2. And 31 minus 1 is our exponent. So we have 0.01 times 2 to the 30th power. Let's evaluate that on a calculator. The amount of money that is received on the 31st day of January is $10,737,418.24. Just imagine how much this would add up to if this question was about summing up the terms of the sequence.